Hey guys, welcome to the show. And today I'm going to certify you. Well, not really, but we are going to talk about certificates. That's not nearly as funny as it usually is it? Hi guys, and welcome to the show. I am honored to have with us today PKI engineer extraordinaire, Senior PFE Wesley Hammond. Wesley, say hi.
Hey, how you doing, Lex?
I'm doing good, man. And I have to mention for everybody that's watching this that I did notice the Darth Vader head on your shelf.
Vader is always watching over my shoulder.
I don't know if that's good. We're doing a security podcast today. By the way, I want to point out that I have a 4.5-foot Darth Vader statue standing right next to me. Yeah, man, there's something about Star Wars that technology people just love.
Star Wars is fabulous.
Yeah, and people seem to really get into the dark side stuff. You see a lot of Darth Vader stuff. I don't see nearly as many Stormtrooper heads out there, but I'm sure there are a lot of them out there. Anyway, just to kind of get to the topic, we're going to talk about PKI, and the whole idea behind PKI is to prevent bad guys, i.e. Darth Vader, right, from looking at your stuff and stealing it.
Correct. So PKI supports a number of different things, which we'll talk a little bit about here in just a few minutes when we start up my slide deck. But for anything from digital certificates to protecting your websites, using data encryption using BitLocker, all of these different things use encryption. So we'll talk a little bit more about that here in just a few minutes.
Yeah. So I have to say that when I started at Microsoft, and I've been here a long time, I've been here 27 years, and I was one of the guys on the original networking team here at Microsoft. And I remember the days when really security in our networks meant, share level security. You attached to a server, and that server had a share on a server, and that share had a password, and it was the same password for everybody. And everything on the wire was essentially sent in clear text, right? Because it's electricity. Who's going to be able to read that? It's got to be secure. It's electricity.
That's right. It's ones or zeros, right?
That's right. There's no way anybody would ever be able to break that. And so we've really come a long way because now, I had a conversation with somebody earlier today, and we were talking about SMB. And, they were confused about what they needed open. They thought they needed 139 open. They thought they needed 445 open. And so I explained the whole thing, right, about how SMB used to require net bias in the old days, but we've gotten rid of that. And that's the only reason that you would listen on 139, because since Windows 2000, we can direct host over 445. And really, there's not really a good reason to pass stuff on 139 anymore. It's not that it's not secure. It's just that it's not really very efficient. And there's a lot of stuff like that. But security in particular has really, really moved forward. We've come a long way from back in the share level security days. And so I'm excited to see what you have to offer us with PKI.
Yeah, it's amazing how many of Microsoft's new products and services really look at having digital certificates to protect them, whether that be an internal certificate authority or getting a certificate from a public certificate authority. PKI is really important now.
Yeah, there's a lot of technologies that start out with different models and different ways to do certain things, but it really feels like from a security standpoint, once we started using certificates and encrypting stuff using certs, that's really the point where things started to take off from a security perspective.
I agree.
All right, so without further ado, let's not bore these guys. Let's jump into your presentation.
Let's take a look. All right, so this is my PowerPoint deck that I have to kind of talk about a few things. The first thing I want to lead into with is PKI, or Public Key Infrastructure, and Microsoft Active Directory Certificate Services flavor of that. And the first question I want to ask is, why is PKI so important? Well, the reason why PKI is so important is, much like Lex and I were talking about a minute ago, is PKI is critical infrastructure for many Microsoft and third-party applications and services. Things like Windows Hello for Business, Windows 10 Device Guard, 8021X, and many, many other services like Smart Card Logons, if you're doing things like Hyper-V Replica, code signing, that goes into Windows 10 Device Guard with code integrity policies as well. Even if you're just signing PowerShell scripts or code integrity policies, it's really important to have a good PKI. System Center Configuration Manager, Windows Intune, 2016 member server clusters, and lots of third-party applications and services that make use of HTTPS, SSL intercept devices, VPN, you name it. So the next thing is a saying here that I've picked up from somewhere. I can't actually remember where I got it from, but a poorly designed PKI can create more risks than it solves. And what does this mean? So first, many customers have existing PKI in place. Many have been around for some time, and like many technologies, the best practices for that technology take time to mature. Many of the ADCS PKI environments may have been built by individuals who have long since left the business. An example of some things that I've seen in the field is auditing. Many PKI environments don't have really mature auditing configured in them. And some of that auditing has been enabled in the newer operating systems. So some questions to ask yourself: do you have an existing PKI environment? And what was the scope of that environment? What was it designed to do originally, and what is it doing today? Many of the environments that I visit in my engagements were designed to do one thing. The organization might have developed that PKI to issue certificates for some internal websites or extranet sites or LDAP-S certificates for the domain controllers. And over the years, that environment scope has moved up into doing things that it may not have been originally intended to do. Like I mentioned a little while ago, the environment may have been built by someone who was no longer there anymore. Was that environment documented? What processes and procedures were documented by the individual? Or was that environment properly documented? What processes and procedures were documented? How about any of the environment's maintenance procedures or the disaster recovery documentation? A lot of the environments that I've seen that have run into trouble over the years tend to stem from a certificate revocation list expiring on the root CRL or on the root. If that happens and you do have an offline root CA, that process is a manual process, and in the event that that CRL does expire, the applications and services will no longer trust the certificates that are subordinated to that root or that root is a parent of until that CRL is published. The last thing that I wanted to talk about here is SHA-1 deprecation. There's a lot of mystery and uncertainty as to what this means and how it affects both internal certificate authorities as well as commercial or public certificate authorities. We'll talk about that in just a minute.
Hey, I've got a quick question for you.
Sure.
SHA-1 deprecation. Is that something that we expect to see moving forward as some of these algorithms, older? I mean, I understand that it's an algorithm, right? So it doesn't
Sure.
go bad.
Much like MD5 and how MD5 was deprecated, and now SHA-1 is actually becoming deprecated.
Yeah.
So
exactly.
as an algorithm gets further and further along in its age, compute cycles and things along those lines have the more powerful processors, and how you have GPUs that mathematically crack things. They have the ability to basically, when it comes to at least the hashing algorithms, cause what are called collisions, which we're actually going to talk about here in just a moment, because I'm actually going to show a demonstration of a SHA-1 collision, because the first one was actually already found.
Yeah. So that's what I'm getting at, right? Is that the longer, like for instance, SHA-1, right? At some point, even though when it was created, that algorithm was pretty secure because of processor speed, because of, the fact that, you've got 50 million people out there trying to crack it, you get to a point where it's no longer nearly as secure, right?
Correct.
But it seems like that's a race. It seems like that's a race that we're always going to constantly be in, right? Because there's always going to be faster processors. There's always going to be newer operating systems. Right now we're 64-bit, but someday, we'll be 128-bit. And then,
Correct.
After that we'll be 256-bit.
Yep, and SHA-1's been around since 1995, I believe.
Yeah.
So it's had a good run. But now it's being replaced by something that's better.
Okay, cool. Yeah.
All right, so these are some real-world scenarios that I have come across in my years here at Microsoft, and just kind of give an idea of some of the things that I find out in the field. And you may or may not be in this type of situation, but if you find yourself in this situation, then you can always reach out to Microsoft for help. So this one here is, my organization has a certificate authority that was built by someone who's no longer with the organization and didn't leave any documentation behind to basically help the folks that were still there. And this is not uncommon. I find this one all the time. Another one, our certificate authority is supposed to issue certificates for 12 months, and now all the new certificates that are issued are only good for 3 months. So back to that maintenance that I talked about a little while, just a moment ago. This typically stems from lack of maintenance documentation, because, like I said, the certificate authority does require to be maintained every once in a while. Every once in a while being a very open term. You have to know what the lifetime of your certificates are, or your CA certificates, and thus the lifetime of your CA certificates determines the lifetime of your subordinates or your end entities certificates. Third, our PKI was built for use with A, but now we need to use it for B. Will it work? Well, the answer to that is maybe, maybe not. You just have to know what the requirements of use B is. And then lastly, the one that we're seeing quite an influx of right now is the existing PKI is using SHA-1. The certificates are signed using SHA-1. And they've heard that Microsoft is deprecating SHA-1. What are the ramifications of that? What should they do with their existing certificate authorities that are leveraging SHA-1 certificates? There are articles out there that show customers how to switch their CAs to signing using SHA-2, but we have found that that may or may not be the best practice to do that. So should they switch to SHA-256 or should they build new? The next section I want to talk about here is SHA-1 itself and the SHA-1 deprecation. And I'm going to call this section here SHA-1 deprecation demystified, because hopefully after you're done watching this, you'll have a good idea of what Microsoft is doing regarding SHA-1. So what is SHA-1, first of all? Well, SHA-1 is a legacy hash function that the security community has deemed no longer secure. Much like DES or 3DES or MD5, SHA-1 has reached the end of its run. And actually, the first SHA-1 collision was detected on February 23rd of this year. If you actually look at the link below, you can actually find some more details about this. But essentially what happens is SHA-1 is a hashing function, which means that you are taking a bit of data and passing it through the hash function to get a digest or a 128-bit hash. When there is a collision, what this essentially means is that two different documents have been detected to contain the same hash. If the two documents that you see here, or the 2 bits of data, contain the same hash, then it is possible that someone could digitally forge a file or a certificate that, or code or whatever have you, so that it actually had a valid signature, but that bit of data is actually a forgery. So is it possible? Yes, but it is still impractical. If you look at the organization that did this, they had a massive amount of compute power that they used to do this. So like I said, impractical, but possible. More likely, this will happen from state-sponsored human adversaries. So governments, nation states that have a large amount of compute that they can use to put towards an effort like this. So this slide includes a graphic in the top right corner and the bottom right corner. But for now, what we're going to focus on is the top right corner. This demonstrates an actual SHA-1 collision. You can see that there are 2 different files here. There are 2 different files here, and they both have the same hash. These were run through SHA-1, and this is actually a SHA-1 collision. These same 2 files have been run through SHA-256, and as you can see from the bottom right image, when they're run through SHA-256, they actually have different hashes. SHA-256, SHA-384, and SHA-512 are the replacement for SHA-1. SHA-256 is currently the standard as it is widely accepted and supported. However, all 3 will work in modern Windows environments. But like I said here, SHA-256 is pretty much the standard right now because it is so widely supported. So Microsoft's definition of SHA-1. Well, the first thing to know about this is that our definition of SHA-1 deprecation only pertains to members of the Microsoft Root Certificate program. If you don't know what that means, that's fine. Essentially what the Microsoft Root Certificate program is a program that is run by Microsoft to determine whose root certificates become trusted by the Microsoft Windows operating system. So if your internal certificate authority is not part of the root certificate program, SHA-1 deprecation doesn't apply to you whatsoever. Now, one thing to know is that even though this is Microsoft's policy on SHA-1, it does not mean that third parties are going to follow our policy. And I know from a fact that there are certain third-party browsers, that shall not be named, that are actually doing this with internal certificate authorities that are Microsoft CAs that are not members of the Microsoft Root Certificate program. They are blocking our certificates. So what is Microsoft doing about SHA-1? So back in 2015, Microsoft announced plans to change the way that Windows applications and devices handled SHA-1. Those plans changed a bit over the time, but now they've been kind of finalized, and here's what they are. The plan was broken up into 3 phases. The first phase, which has since been surpassed by phase 2, back in earlier May, we'll talk about that. TLS secured websites that use SHA-1 and entity certificates or an issuing intermediate. Again, only those that are part of the Microsoft Root Certificate program. The browser no longer displays a lock icon. It still uses HTTPS. It still allows you to go to the site and continue to use it as if nothing was wrong. But it no longer displayed the lock icon anymore. On May 9th of this year, May 9th, 2017, an update to Edge and Internet Explorer was released that will prevent the sites that are protected with a SHA-1 certificate, those like the one above. It will prevent that site from loading and will display an invalid certificate warning. One thing to know about this is more like a speed bump. The user can click past it. So still not completely blocked, but there is a warning. And the third phase is pretty much to warn customers about the risks of downloading software that is using SHA-1 certificates. Just like I showed you in the earlier slide, since SHA-1 hashes can be, since there have been collisions, or there has been a collision detected, it is possible that you could get software or a digitally signed script or whatever have you that could be a forgery. Our goal is to develop a common OS level experience that all applications can use to warn users about weak cryptography like SHA-1. So in the long term, we intend to distrust SHA-1 through Windows in all contexts, but nothing has been done up to this point, and there is no current timeline that I am aware of. Also to know that there currently are no changes to code signing or timestamping certificates as of today. So moving on to premier offerings surrounding Active Directory certificate services. The first thing I want to talk about is some of the new services that Microsoft offers around ADCS or PKI. The first one is the Active Directory Certificate Services Chalk Talk. The deliverables are basically 3 to 4 knowledge transfer topics per day. We have a list of topics that we can provide to customers, and then basically customers choose from the list of topics that they want their engineers to work off of. It is either remote or it's on-site depending on where the PFE is located. There's whiteboarding, lots of knowledge sharing, and PFE-led demos. So a lot of engineers will bring in Active Directory certificate servers, 2-tier PKIs in a lab environment, and basically they will do some demonstration in the PFE-led lab. The next delivery is the Proactive Operations Platform Active Directory Certificate Services Deployment. This delivery provides specific knowledge and hands-on training to design, deploy, and support base operations for a Microsoft Active Directory Certificate Services implementation. The deliverables are Chalk Talk style knowledge transfer, 11 topics in total, 2 being optional. The PowerPoints, whiteboarding, and interactive discussions. There are then hands-on deployment and management experience. There are actually lab exercises in a customer-provided lab. So the customer actually provides a lab environment, and we actually wind up building out a 2-tier PKI with some additional optional things like it says up above. There are 8 over-the-shoulder lab exercises for that, and then also there's a lot of shared best practices that are done in there. The next one is the Onboarding Accelerator. Deployment and Migration Assistance for Active Directory Certificate Services. Here we have 2 different offerings. For the first one, the base offering, there are assessment sessions to evaluate a current Active Directory Certificate Services implementation and discover the current certificate dependencies and the business requirements. We actually have tools that come in and analyze the environment and show you how you're using the certificates that are currently there. There are Chalk Talk sessions and general knowledge transfer to address design and deployment or migration considerations. Planning sessions to define the envisioned design or migration strategy, considering the areas of improvement from the original environment if there is one, identified within the assessment results. And then lastly, a test deployment of the envisioned architecture or migration strategy. This is done in a non-production environment, but the customer will actually deploy their Active Directory Certificate Services that has been designed during this week with the assistance of a PFE on site. In addition to that, there's an optional premium offering that offers assistance with the production deployment, planning guidance, and implementation support. And then lastly, certificate migration planning and certificate and strategy guidance, testing, and a proof of concept as feasible. So one thing to kind of talk about here between the POP ADCSD and the Onboarding Accelerator for Active Directory Certificate Services. We typically recommend that a customer either go through a POP ADCSD or a workshop before they actually go into the Onboarding Accelerator. The reason for this is for customers that lack knowledge in general design, deployment, and management of Active Directory Certificate Services, The POP ADCSD or the workshop give a good background to help support the customer and teach them quite a bit about Active Directory certificate services before they start trying to design an environment in the onboarding accelerator. Some examples of things that we kind of discuss in there would be things like key protections. That is so important nowadays, especially when you're talking about the world of most of your servers living in a virtualized environment. Storing the cryptographic keys on the file system of the servers, is that the right thing to do? Or would it be better to buy an HSM? How are your clients going to be storing their certificates? At what assurance levels? Do they need smart cards? Or should you be leveraging the TPM of more modern devices to help protect those keys? We also talk about the assurance levels, what types of certificates and templates are needed, the ownership of roles. That one's a really important one. Who is going to own the roles that are in the Active Directory Certificate Services environment? And then at what level of high availability does a customer need? Lastly, for the new offerings, we have the Proactive Operations Platform Active Directory Certificate Services Recovery and Execution Service. That's a mouthful, isn't it, Lex?
Oh, yeah.
So what this does is it provides guidance for Active Directory Certificate Services disaster recovery scenarios. Like I mentioned earlier, a lot of customers don't have the documentation to recover their PKI, so this helps with that recovery. In there, we talk about a couple of different things. CA hierarchy recovery, authority information access, and CRL distribution point restoration, the use of key recovery agents and data recovery agents, certificate template restoration, and there are some additional optional modules that you can actually select from as well. And now I want to highlight a couple of our classic services surrounding ADCS. These have been around for a while, but I just want to make sure that everyone knows that these are out there as well, and they have their place as well, and they're very, very important. The first one is our workshop around Windows Server 2012, managing and supporting Active Directory certificate services. So this 3-day workshop, using instructor-led training and Microsoft-provided labs, provides knowledge and skills to design, deploy, and manage an Active Directory certificate services public key infrastructure. Some of the topics that we cover are the understanding encryption basics and the usage of modern encryption techniques, understanding the basics of public key infrastructure, understanding certificates and Active Directory certificate services, understanding how chaining and revocation works, understanding security and support considerations for having a PKI, and becoming familiar with PKI-related features in Windows Server 2012 R2. The last one is the Active Directory Certificate Services Assessment. So this is mostly for existing PKI environments, where it provides insight into the configuration and the health of an Active Directory Certificate Services. Much like a classic health check, it analyzes the Active Directory Certificate Services configuration against Microsoft published and recommended practices. It creates a checklist of elements that are essential to ensuring that the environment is securely and properly maintained, and includes knowledge transfer and whiteboarding. In addition to that, you can also get remediation assistance. However, one thing to understand is that due to the nature of PKI environments and their secure nature, this is only available as an on-site delivery.
Hey, Wes, thanks. That was great, man.
You're very welcome, Lex. Thanks for having me on here.
Oh, yeah, no worries. Hey, one thing that you did mention in the slide deck that I wanted to ask you about was you mentioned that outdated PKI was kind of risky for the customer. And I think there's probably a lot of customers out there that, set up PKI and kind of forget it, because it just kind of works behind the scenes. Can you elaborate a little bit on what some of those risks are?
Sure. So an outdated PKI, or the one that has not really been thought out very well, it could be a real risk because it's kind of the honeypot for bad guys, you could say. Think about it from this way. if your environment, maybe you don't support smart cards in your environment, but what would prevent a bad guy from getting access to your public-private key for your certificate authority and issuing a digital certificate to put on a smart card that had the information for an enterprise admin in it?
Yeah.
That's kind of scary. So it would be very easy for a bad guy, if he was able to compromise the integrity of a certificate authority, to basically get unrestricted access to the environment. Another thing to look,
almost undetectable unrestricted access, right? Because
it looks like the enterprise admin. So,
and everything's encrypted because they're using a cert. It's PKI.
Yep. So it is really important when you're building out a PKI to factor in key protections. What is the scope of that environment going to be? How are you going to protect the keys? All of those different things should be taken into careful consideration before you actually stand up a certificate authority. Who has access to it? Is it going to be on virtualized machines or physical machines? All of these things play into those scenarios.
Awesome. Is there a website or a page that we can point customers to where they can get more information about just PKI in general?
Sure. So we have the Windows PKI blog, which is at aka.ms/PKI blog.
Awesome. That's externally available, correct?
Yes, it is externally available.
Okay. Awesome. That's cool. And so some of the offerings that you mentioned, the POP stuff, etc. Guys, if you're watching this and you want more information about that, please contact your technical account manager if you have one. If not, you need one.
Buy Premier.
Yeah, buy Premier because Premier support rocks. Actually, almost
PKI
all my
rocks.
guests. Well, yeah, okay, all right. I suspect it. PKI rocks. But seriously, almost all of the guests that we have on the show are DSEs and PFEs, and they've got customers, and they're dedicated to making sure that our customers do things the right way. So contact your technical account manager. If you don't have one, get one. Go to the website that Wes just mentioned, AKAMS PKI blogs, I think. Is that correct?
aka.ms/PKI blog.
There you go.
Or you can go to your favorite web browser and search for the Windows PKI blog, and you will find it.
Oh, yeah, there you go. That'll work, too, if you forget the URL. But listen, thank you for doing the show. Certainly appreciate it, and you did a great job.
Thank you so much for having me again, Lex.
Guys, that's it. That's your taste of Premiere.